Hello. In this video, I will tell you a little bit about naming a couple of special kinds of cyclic alkanes. We've learned about naming alkanes with one ring before, but these are two special kinds of alkanes that have two rings. They're called Spyro and Bicyclo, as well as just the regular kind that might have two separate rings somewhere in different parts of the molecule. As I said, there are basically three kinds of alkanes that have two rings. First of all, there's called isolated, where the two rings are separate from each other. They don't share any carbons. There may be other carbons in between the two rings, but none of the carbons could be considered to be a member of both rings at the same time. Then there are Spyro compounds where they share one carbon. They would be of this sort right here, where the carbon in the middle is a member of one ring and it's also a member of the other ring, but there's just one carbon of that type. Those are called Spyro compounds. And then there are bicyclo compounds where they would be more like this, where there are two or three or four carbons that are members of both rings. So the two rings share at least two carbons and maybe more than two carbons. So let's start with the simplest kind. Those are where the two rings are isolated from each other. The rules say we just use normal IUPAC rules. So for example, in this compound, we're going to use that as the base part of the name because it has two different groups attached to it. This one only has one, so this is going to be the base part of the name. And so therefore, cyclohexane is the main part of the name. And then on the cyclohexane, we have a methyl group, and then we also have a cyclohexyl group. Notice that's cyclohexyl with a YL, meaning that it's a modifier of this other cyclohexyl group. So number this starting with that carbon as number 1, because C comes before M in the alphabet, to 3. This would be 1 cyclohexyl, 3 methyl cyclohexane. And that's an illustration of how you name compounds with two rings that don't share any carbons. Here's another example. Now in this case, the two carbons are way separated from each other by two carbons in between, and we're going to name it as basically a 4-carbon chain. On that butane, on the first carbon, we have a cyclopentyl, and on the second carbon, we have a cycloheptyl, and because cyclo-H comes before cyclo-P in the alphabet, we're going to list them in order: 2 cycloheptyl, 1 cyclopentyl butane. Again, just using the same IUPAC rules that we learned earlier on. Now, try this example. Pause the video. It's a little bit tricky, but you can do it. Again, two separate rings with one carbon in between, but no carbons that are shared. In other words, that carbon is only in that ring, that carbon is only in that ring. None of the carbons are in both rings at the same time. So pause the video and see what you come up with for a name. I'm going to click to the next slide. Here's the thought process. Because this ring has two groups on it, we're going to call it the main part of the name, cyclopentane. And we're going to number these carbons number 1 and 2. But what are we going to call these two groups? Well, that's obviously a methyl group. That's just a carbon with 3 hydrogens on it. What is this whole group here? Well, if that cyclohexyl group weren't there, that would just be a methyl group. That would be CH3. But it's a carbon with a cyclohexyl group on it. So it's one of those examples where you have a side chain on a side chain on the main part. So that's why we use parentheses here. So basically, this group is a methyl with a cyclohexyl on it. So it's called cyclohexyl methyl. And that whole group is on carbon number 1. And then the methyl group is on carbon number 2. And the reason that's carbon number 1 is because C comes before M in the alphabet. So this is 1 cyclohexyl methyl, 2 methyl pentane. Oh, and then we should add a trans in front here because on this ring, the two groups, 1 is up and 1 is down. So this is trans 1 cyclohexyl methyl, 2 methyl cyclopentane. Now, here are some examples of Spyro alkanes. Notice that in each case, there is a carbon, that carbon right there, that carbon right there, that carbon right there, that is shared between the two rings. So this is a 5-membered ring in which that carbon is one of the members, and this is a 6-membered ring in which that carbon is one of the members. And so these are what are called Spyro alkanes. One thing to notice here, and I'll point this out again as we go along, it's an easy mistake to make. How many total carbons are there in this ring system? Well, your tendency is to say, well, it's a 5-membered ring and a 6-membered ring. 5 plus 6 is 11. But in fact, there's not 11 carbons here because that carbon is in both rings. There's only 10. So notice this is a 5-membered ring, and then we also have on that 5-membered ring this carbon, this carbon, this carbon, this carbon, and that carbon. So it's a total of 10 altogether. Same thing here. This looks like 4 plus 5 is 9, but it's actually only 8. So count the carbons carefully, and you'll see there's 8 here. And this is 2 7-membered rings, so you might say 14, but in fact there's only 13 carbons there because that carbon is shared in both. Okay, now let's get to the rules. When you're naming spiroalkanes, first thing you need to do is identify the bridgehead. That's easy. It's just the carbon that is shared by both rings. So I put red arrows pointing to the bridgehead in each case. Then you count the 2 bridges, but not counting the bridgehead. So, for example, this is a 1, 2, 3, 4 carbon bridge. In other words, starting at this carbon, if you were an ant, how many other carbons would you have to traverse before you got back to the original carbon? And this is 4, so that's a 4 carbon bridge, and this is a 5 carbon bridge. 1, 2, 3, 4, 5. Also, count the total number of carbons in the ring system. So there's 10 altogether here, as I said before. And so the name of this compound is simply Spyro. So you say the prefix Spyro, and then in square brackets you put the lengths of the 2 bridges in descending order, so it's always the bigger one and then the smaller one, separated by a period, and then the total number of carbons in the system. So as we said, there's 10 carbons altogether, so that's decane. So the name of this compound is Spyro 5,4-decane. Same idea here. This is a 4 carbon bridge and a 3 carbon bridge. How many carbons altogether? 8. And so this is Spyro 4,3-octane. And another example, same idea. 6 carbons in this bridge, 6 carbons in this bridge, and 13 altogether because of the bridge head. And so this is Spyro 6,6-tridecane. Tridecane is the alkane with 13 carbons. So there you have the main idea of how you name spiral compounds. But we still have to think about what if you have any groups attached to the rings. How do you number them and indicate their numbers in the name? Take a look at this one, which is the same as the example we saw a minute ago, but as a methyl on this carbon right here. So what does the rule say in terms of numbering? Well, this is really important. It's a little bit tricky. You number the longer of the 2 bridges. No matter what groups are present, you number the longer of the 2 bridges. Starting at the bridgehead is carbon number 1. So the bridgehead will always be carbon number 1. And you number around the longest one. In which direction do you go around the longest one? You go in which direction will get you to the first branch point as soon as possible. So we're going to call that 1, 2, 3, as opposed to 1, 2, 3, 4, 5, because 3 is less than 5. Then you skip to the second bridge if you need to. So for example, in this case, we don't have a methyl group on the 6-membered ring. So again, we start at that as the bridgehead. The question is, shouldn't we go to that as number 2? Because that's where the first branch point is. And the answer is no. This is very important. You number the longer of the 2 bridges first, and then you number the second longer bridge if you need to. So this is 1. And in this case, since there are no groups on the 6-membered ring, it doesn't matter whether we go 1, 2, 3, 4, 5, 6 as I've shown, or 1, 2, 3, 4, 5, 6. But in any case, once you get back to the original bridgehead, you don't give that a new number because it's already number 1, so you skip to the second one. So you're literally skipping that carbon right there, and you're going to call that number 7. The reason we call that 7 instead of that 7 is because it's closer to the first branch point. What about in this case? Here we have 2 methyl groups, one on the 5-membered ring and one on the 4-membered ring. Again, we're going to start numbering carbon number at the bridgehead as carbon number 1. But we're going to go around the longer of the 2 bridges first. That's always true. No matter what groups are present or where they are, you always do the longer bridge first. So we're going to go 2 and 3 that way. Even though this methyl group would be closer if we went this way, we can't because this is a longer bridge. So that's 1, 2, 3, as opposed to 1, 2, 3, 4. Again, you go whichever direction will get you to the first branch point first. So this is 1, 2, 3, 4, 5. Then again, we skip that carbon and we go to number 6. So that second methyl group is a carbon number 6. Here's another example. Again, that's carbon number 1. Again, that's carbon number, the longer bridge first, and this is a longer bridge, but that wouldn't matter in this case because there are no branch points on this one anyway. But here the question is, do we number this way as 1, 2, or do we number this way as 1, 2, since the first branch point is equally distant in both cases? Well, since E comes before M in the alphabet, we're going to number this way. So 1, 2, 3, 4, 5. Here's another example. Notice that in this case, there are 3 methyl groups there. Since the 2 bridges are the same length as each other, which one are we going to number first? Again, we're going to start at the bridgehead as number 1. That's always true. Well, we're going to number around whichever one will get us to the first branch point as soon as possible. If the 2 rings are the same size, you don't have any guidance about which ring to number around first, so you fall back on the first branch point rule. So notice that if we start here and go this way, 1, 2, 3, we get to the first branch point at carbon number 3, whereas if we started at 1 and went around this way, 1, 2, 3, 4, we wouldn't get to the first branch point until carbon number 4, or this way, 1, 2, 3, 4. So this is the preferred way because it gets us to the first branch point as soon as possible. Even though this ring has 2 groups and this ring only has 1, we're going to number around whichever direction will get us to the first branch point as soon as possible. So 1, 2, 3, 4, 5, 6, 7. Then we skip that carbon and we go 8, 9, 10, 11. In this case, we could have gone 8, 9, 10, 11 that way as well because the 2 are equally distant from the bridgehead. And what about here? Again, 2 rings are the same size as each other, so what do we use in terms of guidance to decide which ring to number around? Well, we get to the first branch point. Which one will get us to the first branch point as soon as possible? Well, if we go this way, 1, 2, 3, we get to the first branch point at carbon number 3. If we go this way, 1, 2, 3, we get to the first branch point at carbon number 3. So we still can't decide which one to number around based on first branch point. So what we do is we fall back on alphabetical, and since E comes before M in the alphabet, we're going to number around this way. So 1, 2, 3, 4, 5, 6, 7, and then we jump to 8 and then 9. Then you write, as you would with any other alkane, you write the substituents with the numbers in front of the Spyro part of the name, and it will still have the brackets with the numbers separated by a period and the total number of carbons in the ring system at the end. So here are the numbers that I've given you on the previous slide. See if you can take a minute and come up with the correct names for these. So pause the video and do all 6 of these examples and write out a complete name for them. What about that one? That's going to be called 3-methyl Spyro 5,4-decane. We saw why it's called Spyro 5,4-decane in a previous slide. And since the methyl group's at carbon number 3, as we saw, it's just 3-methyl. Now notice that there's no space between the methyl and the Spyro, and there's no space between the Spyro and the bracket or between the decane and the bracket. It's all run together. Just as we saw, for example, methyl cyclohexane, there's no space between the methyl and the cyclohexane. Next one, this would be called 7-methyl Spyro 5,4-decane for obvious reasons. Next one, this would be called 3,6-dimethyl Spyro 4,3-octane. This would be called 2-ethyl 5-methyl Spyro 4,3-octane. Next one, this would be called 3,10,11. Because there are 3 methyls, we have to have 3 numbers in front. So 3,10,11 trimethyl Spyro 6,6 tridecane. And finally, this last one, 3-ethyl 9-methyl Spyro 6,6 tridecane. So now you know how to name Spyro compounds. Now let's do a little bit more complicated system, and that's bicyclic alkanes. I've drawn here 5 examples of bicyclic compounds, or bicyclic alkanes. You can find many more in the book and all sorts of them online. Just put in bicyclic compounds and you'll get tons of images. Anyway, rule number 1 says identify the 2 bridgeheads. Now with Spiros there is only 1 bridgehead because they only share 1 carbon between the 2 rings, but with bicyclics there will be 2 bridgeheads. And they may be right next to each other, as in this case, or they may be separated from each other, as in these cases. But you can identify a bridgehead. If you are an ant on one bridgehead and you start walking, you can go around a bridge and get to the second bridgehead. Starting at that same first bridgehead, you can walk around another bridge and get to the second bridgehead. Or you can start at the first bridgehead, walk this pathway and get to the second bridgehead. There will always be 3 pathways between the 2 bridgeheads, and they will always be unique. In other words, none of the carbons in this path are the same as these carbons in this path, nor the same as these carbons in this path, which obviously there are no carbons in this path in between. But they won't share any carbons between the 3 different pathways. So let's just take a look. In this one, again, a 3-carbon bridge, a 4-carbon bridge, and a 0-carbon bridge. Take a look at this one. A 2-carbon bridge, a 2-carbon bridge, and a 1-carbon bridge. In this one, a 1-carbon bridge, a 1-carbon bridge, and a 1-carbon bridge. In this one, a 1-carbon bridge, a 2-carbon bridge, and a 4-carbon bridge. This one's a long one, 4 carbons in this pathway, but to get from this bridgehead, you follow along this pathway and you get to the second bridgehead without crossing either of these carbons or that carbon. So, not too bad in most cases to pick out which are the 2 bridgeheads in a bicyclic compound. Next rule, just like we saw with the Spiros, count the 3 bridges. Now in the Spiros there were 2 bridges. In the bicyclics there will always be 3 bridges. So count the bridges but not the bridgeheads. Just as we saw with the Spiros, you don't count the bridgehead. So as we saw before, this is a 4-carbon bridge, this is a 4-carbon bridge, and this is a 0-carbon bridge. So this compound is going to be called bicyclo. So what you do, use as a prefix, not Spyro as we saw in the other cases, but bicyclo. And then you put in brackets, just as we saw with the Spiros, 3 numbers this time. Not 2, but 3 numbers, all separated by periods and in decreasing order, so 4, 4, 0. And then you just say the name of the total number of carbons. In this case, there are 10 carbons altogether. Now you might stop and say, but isn't that 12? Because it's 2 6-membered rings. And don't forget, these carbons are shared by both. So this is a 6-membered ring, 6 carbons there, and then you have 7, 8, 9, 10 carbons altogether. One little trick, the number of carbons altogether will be 2 more than the sum of these numbers in here. Since the numbers in here are equal to 8, that's 2 more. 10 is 2 more than 8. And the reason it's always 2 more is because there's bridgeheads that aren't included in these bridges. Okay, so this compound would be called bicyclo 440 decane. This compound would be called bicyclo 430 nonane. It has a 2, a 2, and a 1-carbon bridge, so it's going to be bicyclo 221. And the total number of carbons here is 7. Again, notice it's a 6-membered ring with 1 extra carbon, so it's 7 altogether. And again, notice that that number is 2 more than these numbers total. That totals to 5, that's 7. Let's move on. This would be bicyclo 111 pentane, because it's a 1-carbon bridge, a 1-carbon bridge, a 1-carbon bridge. Bicyclo in front, numbers in the bridges, and then the total number of carbons in this case is 5. And this compound would be bicyclo 421 nonane, total of 9 carbons in this system. And notice that these numbers add up to 7, so it makes sense. Now, what if you have groups attached on there? Well, then you get rule number 3. The rule says start numbering the compound, and just like with the Spiros, you start at a bridgehead. But now it's a little more complicated because you have 2 bridgeheads. With the Spiros, you just had 1 bridgehead, and so it was automatically number 1. But now you have to choose which of the 2 bridgeheads am I going to start as number 1. First of all, you have to go around the longest bridge. In this case, this is a 4-carbon bridge, and this is a 4-carbon bridge, so that doesn't help us. And then you have to use whichever one will get you to the first branch point as soon as possible. So if we start that as number 1, and we go this way, we'll get to the first branch point of carbon number 2. If we started here, we'd have to go all the way around there to get, and we wouldn't get to the first branch point until carbon number 1, 2, 3, 4, 5. Or if we started here and went this way, 1, 2, 3. Or if we started here and went this way, 1, 2, 3, 4. So this is the bridge you want to use, and that's the direction you want to go. So 1, 2, 3, 4, 5, 6. Notice that when you get back to the second bridgehead, it gets a new number. And then you start around the second longest bridge, which in this case is also a 4-carbon bridge. So that's 7, and that's 8. So this is 2, 8 dimethyl 440 octane. This one, are we going to number from here, or are we going to number from here? Well, in this case, it's easy because this actually has a branch right on it, so that's carbon number 1. This doesn't have a branch on it, so that's not carbon number 1. And then the rule says you have to go around whichever of the 2 bridges is longer. Now in this case, this is the longer bridge. A 4-carbon bridge is longer than a 3-carbon bridge, so we've got to go around this way, and then we're going to start numbering the second one. So in this case, 1, 2, 3, 4, 5, 6, 7, 8, 9. We don't get to the second methyl group until carbon number 9. And you might say, well, that's silly. Why don't we just start at that as number 1 and go this way as number 2? But the reason is, and you need to think carefully about why that rule is there. If that was 1,2 dimethyl bicyclo 430, what would you call the compound that had a methyl group here instead? That would also be 1,2 dimethyl bicyclo 430 nonane. And you can't have 2 compounds with the same name. So that's why that rule is there. You have to go around the longer bridge first, even though it may take you a while to get to the second branch point. So 1,9 dimethyl bicyclo 430 nonane. This compound we're going to start at carbon number 1, and we're going to go around this bridge first or this bridge first because they're both 2 carbon bridges. Well, the fact is we're going to go this direction because we get to the first branch point sooner there than we do there. And if we start at this other bridgehead down here, we don't get to first branch point until carbon number 3. So 1, 2, and then we're going around 3, 4, 5, 6, and then we skip this carbon because that one already has number 1, and we go to the third bridge, which in this case is just a 1 carbon bridge, and that becomes carbon number 7. And notice in these 2 examples we didn't have to go to the third bridge because there's no carbons in the third bridge. That's a 0 carbon bridge. But this one is a 1 carbon bridge, so it needs its own number, so that's carbon number 7, and that's where the methyl group is. So this is 2,7-dimethyl bicyclo 2,2,1 heptane. What about this one? Well, now all 3 bridges are the same length. This is a 1 carbon bridge, a 1 carbon bridge, and a 1 carbon bridge, as indicated by the 1, 1, 1. So how do we decide which of the 3 bridges to number first? Well, whichever one gets you the first branch point as soon as possible. So we're going to use this as the first bridge, so that's carbon number 2. If we had to, then that would be 3, 4, we'd skip the first bridgehead, and that would be number 5. So this is just 2-methyl bicyclo 1,1,1 pentane. And finally this one. Now this is actually the easiest one because all 3 bridges are different lengths, so clearly this is going to be your bridge you're going to number around first. Do we choose this bridgehead or do we choose this bridgehead? Well, in this case, we're going to choose that bridgehead because it gets us to the first branch point sooner. And so this is just 2-methyl bicyclo 4,2,1 pentane. Now, here are some examples for you to I would stop the video at this point and try to name those compounds. And then once you're done, restart the video and I will reveal the names for you. Everybody ready? Okay, here are the names. And I'll let you work out why those are the correct names. If you have something different, see if you can figure out why. And here are some more compounds for you to work on. And again, pause the video, and when you're ready, restart the video, and I will reveal the names, and you can see if they are what you got. Now, go back and reread section 2.4b and see if it makes more sense to you. Thank you for your attention.